All right, guys, I'd like to introduce Ritesh from 128 Technology. They're actually the sponsor to make this event happen for yesterday and today. So we're going to have a slight change in topics and talk about some interesting things that he's doing in the WAN space, and also like mention how that applies, how we can also apply really efficient automation and operations of next generation WAN technology.
Thanks.
We'll take 2 seconds.
The good part about sponsoring is we get to talk about any topic, but I'm going to keep it short. Okay, it's only 10 minutes. I'm not going to do more than that. But I'm going to talk about who we are and a new way of routing that we are doing, and how we are going to exchange information and everything else. Let's go ahead with that. We call 128 Technology. Even though we are completely IPv6 compatible and all that, but it's nothing to do with the number of bytes or anything like that. It's just the name of the highway around which we are based. 128 Technologies, Route 128 in Boston. That's why we are called 128 Technology. We are about 4.5 years old. We have a little more than 100 people now, and we're based in Boston. We make session smart routers. The difference between us and traditional routers is traditional routers forward things based on what they see in the backend. They're stateless. In our case, we keep state per flow that we see in the network for the duration of the flow, and we forward based on that. The advantage of doing that is we don't need to do any encapsulation, so we don't have any IPsec, we don't use any VPN technology. The advantage is that we don't add any encapsulation headers, so immediately there's a lowering of bandwidth usage in the network. It's very high capacity, high scale, works great. We are growing, and over the last year or so, we have about 100 customers. Most of them are based in US, Europe, and Japan. That's the only 3 markets we currently work in. And of course, we're expanding to other regions. If you haven't looked at our technology, please take a look at the website. I'm not going to talk about that today. What I'm going to talk about is session-based routing and how we're using things to exchange information about routers. Before I go ahead, the idea of today's summit is obviously automation. We are a completely software-based router. We only make software. We don't make any hardware. You run us on a white box, it becomes the hardware. So we're completely programmable. We can use any DevOps tools to program us, and so on. Today I'm going to talk about routing, but you can also use DevOps tools to influence the database to make sure that the network performs as you require. If you look at traditional routing protocols, traditional IGPs, BGP, OSPF, ISIS, any of these, they're very good at doing connectivity. And of course, they're working today, they work and the internet works today. They're very good at doing connectivity. However, they're not good at sharing current load and capacity information. They're not good at telling what the performance of the network is. There are extensions to communicate many things to these protocols, but still, many network users today, like Google and others, they've actually removed BGP and other things from their network because they didn't find it that useful. And the reason for that is it has a lot of overhead. It communicates hop by hop things, and has poor reconvergence. It's not suitable for modern applications. What we have done is we've come up with a new way of sharing information among routers. It's called STEP. We call it Service and Topology Exchange Protocol. The idea is we can use high-speed in-memory databases to share information among routers. Just like you can share a file today with millions of users using Dropbox or Drive or anything like that, we can do the same way, share routing information on network to load information among all routers. So everybody knows what the state of the network is, and they can forward packets accordingly. Obviously, we don't need to tell them everything about the network, just like Google Maps. It only tells you what you need to know. For example, it'll tell you the traffic between you and the office today is this. It doesn't tell you what's the traffic in London right now. That's not important for you. Of course, if you want, you can also see that, but then it'll go and get that data. This results in a superior performance. There's low overhead. Reconvergence is really fast. And like I said, this database, you can also influence using DevOps techniques. You can write DevOps tools which influence the data, and that's how the network pathways will be selected. This is very suitable for cloud, 5G, and modern applications. The idea is basically you have regions in the network. Depending on these regions, all routers, they make a file, like a JSON file, which is human readable, which has service and topology information. We put this file in registry, and using high-speed in-memory databases, We exchange this information among all the routers. So it's all the routers have a push-pull model. They get the diffs only. It's just like GitHub. You don't download all the files, you only download diffs. So it tells you the diffs every time, and it tells you the diffs of what the information is. So by doing this, for example, all routers, they monitor paths among themselves using BFD to get delay, jitter, and other information. This is communicated to the database tells everybody. So now the entire network knows what's the delay, jitter, and load in different regions in the network. So I can tell you at this time, it's probably better for me not to take the shortest path, because the shortest path is congested. It's probably better for me to take the longer route. We can make these calculations in routers today. Just like Google Maps, it tells you during 8 to 9 tomorrow morning, traffic is going to be congested, so don't take the highway, take the scenic route right now. Same way we can do that for networks. It's also source-based calculation in the sense the source calculates the entire path in the network and tells the packets how to go. We can also use it for elastically growing services. For example, let's say you have a service which is in your data center and you have packets going towards it. By telling the database, using any DevOps tools, you would program the database would tell everybody, load is high now, so there is a new service in that same AWS. You start using it, all the routers know about it, they send new sessions to the service in AWS, or you can load balance it any way you want. So using these techniques, we can of course grow, add, remove, modify services dynamically in the network. The best part about it is also visualization. Since I have the data in a single repository and I have diffs telling me what happened over time, I can play it like a YouTube video, like a heat map. I can play it in the network and it tells what's happening in the network, what time loads change and so on. I can also do a lot of predictive analytics. For example, if I know 3 changes in the network, I made 3 upgrades in the network and it caused a failure. The next time you do 2 changes, I can tell you, you make 1 more. Last time you had a failure. So I can predict things for the future. Just like Google Maps does, it can tell you the traffic tomorrow at 8 o'clock, what's the traffic to reach home or office. It's doing that based on the data it has. We can do the same thing from networks. You can also keep an eye on critical services. You can replay the whole thing. You can go back in time and see what happened when. And of course, the main idea is you would use it to resource allocate things in the network. Once you know loads, every day 5 o'clock, this route is congested, you can add more resources there. We can also use it for exchanging multicast participant info. For example, if new receivers join, the database can tell everybody where the receivers are and you forward traffic accordingly, building the perfect multicast tree. You don't have to keep bin state in all routers, you don't have to go to beer or anything else. We can also do a lot of analysis since the database has configs of all the routers. It can tell you, for example, you can do checks. Let's say you have one router using AES-128 and another using AES-256. In an ideal world, you would have to go through the configs of each routers, but since we have all the information in the database, we can do a sync and tell you in advance what errors and configs are there, what changes are there, what doesn't work, and so on. We can alert the user. Having said that, to sum it up, the services topology exchange protocol helps with service discovery. You can elastically grow, add, modify, remove services. It gives you the best path on the network all the time. The best path for the service. Doesn't have to be the shortest path, but the best path at this point to reach anybody based on rules. You can do a lot of cool analytics and heuristics. You're even able to proactively predict things for the future. And of course, it helps establish security and trust in the routers. These are some of the things you're working on at 128. I know it's a little different from what you guys have been discussing. We also do DevOps and everything else. But having said that, I wanted to give you a glimpse of what we are using to communicate network information state to all our routers. Any questions or comments, please?
Is this, you may not be, want to answer this, but is this in the end a good data network?
So, good question. All our routers are configured. It is similar to named data networking in the sense, but named data networking is towards content. In our case, what we do is towards services. In the sense you could say a service is Facebook and it's located on the internet, and internet is 10.10. And once you tell one router that, all routers in the network understand to do that. So next time when you want to configure anything, you just say, give sales access to Facebook. You don't configure IP addresses anymore. But it's slightly different in the sense, internet networking is towards content, and this is towards services. But that's services defined by you where the content is, and you just say, Salesforce is at the internet, give sales access to Salesforce. Any other questions?
One more here.
Go ahead.
So I'm assuming that your technology is interoperable with other router versions, right? It is not necessarily from the session-based router.
So today,
How does it work?
no, good question. The answer is yes, but today our routers are the only ones who use this. But having said that, the database can be accessed. It's like I said, so on purpose we made it JSON human readable files, so it's easy to compile. So anyone could write an API to take that information in and populate any other routers as well. But having said that, our routers are the only ones who use this today. But it's open in the sense there's no.
No, the question is not that. The question is, let's say the router is your technology to a network where there are other routers which do not support session-based router.
Oh, okay.
So the idea is how
So we also do BGP, OSPF, ISIs internally to learn network routes and everything else from other routers, like Cisco routers, Juniper routers, and other things in the network. But we do this session-based routing only when we see there is an upstream 128T router. In the sense, if the router knows that there's an upstream, he'll do the session-based routing. The routers in the middle, they have no idea they're doing session-based routing. They just forward packets as normal packets. They just think they're forwarding normal packets. But that's what it will do. And in case, you're right, I mean, there is a possibility there's no router out there which is 128. In that case, we will not do session-based. We will just do normal forwarding. Yeah, that's the disadvantage because everyone is not doing session-based. You need at least two to take the advantage of session-based routers. Yeah. Any other questions? Okay, thanks a lot. Thank you, everyone.